This is the 310 to 311 review. Calculators are allowed, though you probably won't need them for a lot of these problems. Number 8, a railroad track and a road cross at right angles. An observer stands on the road 50 meters north of the crossing and watches a westbound train. So in this particular case, for step 1 of the process, we're going to want to draw a right triangle to indicate that we have things crossing at right angles. The right triangle is going to be oriented in a way that we have the observer north of the intersection and then a train traveling west. So remember, in step 1, things that are changing over time will be receiving variable labels, whereas things that stay the same are left alone. So in this case, we have the observer who is standing. He's not moving, so we can label this piece as 50 meters. We also get information about how quickly that westbound train is traveling. So that means we're going to put an X here because we know dx dt. And to remind ourselves to pay attention to whether X is getting larger or smaller, we will put an arrow on it to indicate the direction in which the train is traveling. So X is going to be getting bigger as time moves forward, which means the train's rate, or dx dt, is going to be a positive number. Now the next part of this says, at how many meters per second is the train moving away from the observer? So that means we're interested in the rate at which y is changing. Oops, sorry, that should be want dy dt. So step 2 of the process is to now write a single equation that relates the x, whose rate we know, and the y, whose rate we want. Looking at the picture, we can see that Pythagorean's theorem will connect the 3 together. So I can say x squared plus 50 squared equals y squared. Step 3 of the process is to take the derivative with respect to t on both sides. If I take the derivative of the left side, I'll get a 2x dx dt plus the derivative of the constant is simply 0, and on the other side we'll get 2y dy dt. Now step 4 and 5 kind of work together. With step 5, our goal is to plug into this related rate equation that we have now everything except for the thing that we want. So that means we want the dy dt, and everything else we should be able to figure out, either from what was given or from relationships on the picture. So we are told that the train moves away from the observer for 6 seconds. So with step 4, we would label x as 6 times 40. So we know at the instant in time we will have 240 meters as our x. We also know dx dt, which is how quickly the train is moving, so how quickly that x is changing, and that is the 40 meters per second. On the other side, we need to know what y is. Well, y will be the square root of 50 squared plus 240 squared. So actually I'm going to put parentheses around this and just put the y at the back. Notice in step 5 now that we have figured out every variable that's in the equation except for dy dt. So now we can isolate it. Step 6, we're going to isolate that dy dt, which means we're going to multiply these 3 together, and then we're going to divide by the 2 and the root. So I guess you will need a calculator for this, and my hope is that you will be smart in how you enter this into your calculator. You don't have to do the top separately from the bottom and try and track through all of that. You can enter the entire thing in one step. So if you enter the top with parentheses around it and then divided by, enter the bottom with parentheses around it, you can get the entire answer, which in this case ends up being about 39.159 meters per second. Now this is going to be a multiple choice problem, so you will not have to put the interpretation, but if you were, you would say the train is moving away from the observer at a rate of 39.159 meters per second. Or you could say at the instant in question, or when the time is 6 seconds after the train has passed the intersection, this length y is increasing at a rate of 39.159 meters per second.